All right, so this is lesson 3. This is our last lesson for Learning Guide 1. As you guys can see, we're talking about exploring congruent triangles and proving congruent triangles. So first of all, what the heck is a congruent triangle? It's saying that triangles are the same shape and same size. Okay, so we're looking at basically proving that two triangles are exactly the same. They have the exact same sides, they have the exact same angles. And it might seem kind of obvious, like, well, we can just look and see. Sometimes they're manipulated in a way that we can't exactly tell, or we may not be given enough information to exactly be able to tell if they're congruent triangles. So there's some rules that we're going to talk about that will help prove this. So it's saying here, every triangle has 3 angles and 3 sides. If all 6 corresponding parts are congruent, then the triangles are considered to be congruent. So if we take a look here at these triangles, if we know that these are congruent triangles, that means that angle A must be equal to angle D. So we literally know angle A is equal to angle D. Same thing, angle C must be equal to angle F, and angle B must be equal to angle E. Same thing with our sides. Again, because it's congruent, I know that, well, this side, AB, must be equal to DE. And AC must be equal to DF. And then last one, CB must be equal to FE. Okay, so again, just congruent triangles, everything's exactly the same. We have a couple rules because, like I was saying, sometimes we're not going to be given all 6 pieces of information, like all the angles and all the sides. So what we're going to need to do is actually look to see some rules that kind of help us take a few shortcuts. So it's saying we can determine 2 triangles to be congruent by using congruent postulates. So it kind of sounds weird, postulates. Basically, all this means is just some rules that we can remember that help us do this a little bit easier. The first rule is called SSS, and SSS stands for side, side, side. So if we know the sides of one triangle, so all these sides, if those are congruent to all of these sides, then we have to know the triangles are going to be congruent. Pretty straightforward. If we look at the next one, it's saying SAS, which stands for side, angle, side. So if 2 sides and the included angle, I'm going to stress that, the included angle of one triangle are congruent to the 2 sides and the included angle of another triangle, the triangles are going to be congruent. So guys, it's really important that we note that it has to be the included angle. So what I mean by that is, let's say I know this side and I know this side. I know this side and I know this side. This is the angle that must be the same. If I know, let's say on a triangle, this side, and I have this angle, that doesn't follow the same rule. I can't use SAS. So again, you just kind of follow it in order. S, A, S, S, A, S. This one would be A, S, S, which all of you know we're not going to teach you a rule that is called AS. Now we're going to finish up here on our last one, which is called number 2. Sorry, that's a typo. This should be number 3. Okay, and this one's called ASA. So again, has to be in that order, angle, side, angle. So if I know, again, we'll just read it out. If 2 angles and the included side of one triangle are congruent to the 2 angles and the included side of another triangle, the triangles are congruent. So if I know this angle, this side, and this angle, so see how the side is included between those 2. If that's equal to the same thing on the other one, we know that it's congruent. Now, one thing that you may have noticed on the other page is this kind of symbol here. That symbol literally means congruent. So we would say basically like triangle ABC is congruent, triangle, let's say DEF. That again means everything is equal. So let's take a look at some examples here and kind of see what your questions are going to look like. It's saying, are the following triangles congruent? Why or why not? So we just talked about 3 rules that we can use. We've got SSS, we've got ASA, and we've got SAS. So we're going to be using one of those three rules in each of these cases to prove that they're congruent. So if we take a look at this, guys, obviously we've got a side, we've got a side, we've got a side. In here we've got a side, we've got a side, we've got a side. So if we know that all three sides match up with all three sides, we know that yes, they are congruent. Why? Because of the rule side, side, side. Now, what does that mean? Well, if they are congruent, then right away I know that angle C must be equal to angle F, and angle A must be equal to angle D, and angle B must be equal to angle E, which is kind of cool because you guys know in this learning guide we have to solve for angles. It's saying if the triangles are congruent, state the congruent statement. What that means is our congruent statement is this guy right here. That's our reasoning. Okay. Name that postulate. Again, the postulate is basically the rules that we've talked about, so SSS, SAS, and ASA. Here, our first example is called something called the reflexive property. And the reflexive property is when the two triangles share a common side. And when they solve a common side, which is right here, we automatically know that this side has to be the same for both triangles because it's literally the same side. It's literally that same line. So if I follow this across, in this first triangle, I've got a side, angle, side. So I've got side, angle, side. If that matches the other triangle, then we're good to go. So let's take a look. In this case, I've got a side, which matches, an angle, which matches, and a side, which matches. So yes, they are congruent, and the reason would be side, angle, side. Take a look at the next one, saying vertical angles. Vertical angles, remember guys, we know from our X rule that these have to be exactly the same. So if we look to see, okay, well, are they congruent? Well, you might be on the right track here to say yes. This side, angle, side, side, angle, side. So yes, they are congruent, and the reason is SAS. Again, this is another example quite similar to the last one. We've got our side, angle, side. So side, angle, side. In our other triangle, side, angle, side. And everything absolutely matches. So SAS, and we're good to go. Reflexive property, kind of the example on, or it's kind of just like the first example that we did. In this case, it's a little bit trickier. We know that this side is the same. If I just focus on this left triangle for right now, I have an angle, and I have a side, and I have a side. So remember, if I go in that order, angle, side, side, uh-oh, that's definitely not what we want. We need to have that angle right here. So because we don't have it, we definitely cannot tell that these are congruent. So we don't know. We're not given enough information. Let's look at some more of these. So again, name that postulate. It's saying, are they congruent or are they not? And if they are, how do you know they are? So let's go through. Side, angle, side, matches, side, angle, side. Yes, they have to be congruent. Let's look at this one. Angle, side, angle. Matches, angle, side, angle. That's good. So far, so good. They're all going to be congruent. What about this guy here? If I go in order, I either have side, side, angle, and then side, side, angle. So we know that that's no good. I can't have SSA. And then if I go the other way, angle, side, side, angle, side, side, again, that's no good. None of those go with any of the rules that we've talked about. So this one, we cannot say that it's going to be congruent necessarily. And then the last one, we've got side, 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 side. So that does apply to one of our postulates. So we're good to go there. Our last example is a little bit more putting this in context of what you guys are going to be doing. So it's saying, given that TP is perpendicular, so I know that this in your notes is really light, so you might want to write that down for yourself. So TP is perpendicular to AC. So what does that mean? TP is perpendicular to AC, which means that we've got 90-degree angles there, which is good. If we know that AP is equal to CP, so AP is equal to CP, so AP is here, CP is there, prove that TAC is isosceles. So prove that TAC is isosceles. Basically what we need to do in order to prove that it is an isosceles triangle, so TAC, if I look at TAC here, isosceles means that this angle, or this side and this side have to be exactly the same in order for it to be an isosceles triangle. Now, if we can prove that those are the same, then we're also proving that TAP and TCP are congruent triangles. So this kind of goes with what we've been talking about. And so in order to do that, if you guys look, I've got a side here. There's actually multiple ways of doing it. If this side and this side, okay, we know that those are the same. We know that these angles are the same right here. And if we can prove, again, remember SSS, SAS, or ASA, if we can prove one of those, then we've proven that this is a congruent triangle. So let's take a look. We know automatically, guys, that TP is equal to TP, right? It's the same line. So we can write that out. We know TP is equal to TP. And again, what's our justification? Well, it's the same line, so it's pretty obvious here. We know that TPA, so angle TPA, is equal to angle TPC, and both of those are equal to 90 degrees. What's our justification? Well, it's a perpendicular line. According to this information, we know that triangle TAP and triangle TPC have to be congruent. What is the reasoning? So this is, again, kind of what we were doing. How do I know that these triangles are congruent? Well, I've got a side, I've got an angle, and I've got a side. I've got a side, I've got an angle, and I've got a side. So side, angle, side is going to be our reasoning for that. Again, the question is saying, prove that TAC is isosceles. Well, in order to do that, remember, I need to prove that TA is equal to TC. Well, we can do that because we now know that they're congruent triangles. So TA has to be equal to TC because of congruent triangles. And in proving that they're congruent triangles and in proving that this side is equal to that side, we now know that it must be an isosceles triangle. So there's just kind of an application way of looking at all the information that we were just talking about it throughout this whole learning guide. Now the last little bit, guys, again, how to be successful. Please don't forget every single night doing your homework, page 106 and page 113. So this is what you should be doing tonight and coming to see any of us teachers at the help desk to go through it with you. And then basically, guys, you can be finishing up your entire assignment now because that is the end of Learning Guide 1.